Welcome to the Paper Airplane Lab, and hopefully you've already found this document in Canvas and opened it up into Google Classroom. This is going to be some quick instructions on how to do this lab. First off, a big overview of the lab. It simply says what will happen to the average speed as you throw a paper airplane up to 4 meters. So you're going to throw a paper airplane 1, then 2, then 3, then 4 meters. And you're going to time it. Of course, you got the distance. And you're going to then graph the average speed versus the distance. And so you'll need to make a hypothesis as to what do you think will happen to the average speed of the paper airplane as you throw it these 4 different distances. If you want to take a moment now, you can do that, or continue watching the video. Here is our background information, and we learned about how to calculate an average speed. An average speed is just taking the total distance divided by the total time, and I've got here an example problem for you. Then it instructs you to figure out how to time this thing. And so I'm going to show you on my iPad how to open up a clock, and then I'll explain throwing the airplane. Okay, so on just your regular screen on your iPad, find this little app. It's a clock. Looks like a clock. It's pretty obvious, but when you open it up, it has other information on here. You can set it for an alarm clock. You can see where it's at or what time it is in different parts of the world. And of course, here's what we want to use it for. Here is the alarm clock. I'm going to hit the reset button, and then of course, if I hit the start and stop, it'll time how long something happens. Okay? So let's take a look at how you're going to actually do the lab. So let's take a look at the setup that you're going to do. You need to find a room that is at least 4 meters long. Okay? So you're going to throw it 4 meters. If you want to throw it farther, that's fine, but I'm only asking you to do it out to 4 meters. Now, how big is a meter? Well, if you were to, here you are standing in your house, if you were to take a big step, some people do this for yards, but a meter is just a little bit longer, so you got to take a little bigger step than a yard step. So take one full big step and use something to mark it on the floor or outside. Take another step, 2 meters, 3 meters, and 4 meters. Okay? And then you're going to simply take your airplane that you built and you're going to toss it and time how much time it took to go that distance. You're going to do it 3 times, and then you're going to throw it a little farther and time that. Throw it a little farther, time that. What happens if it's not exactly on the 3 meter mark? Try it again. If you're like way over here, but try it again. If it's really close, you decide what is good data. Then you're going to throw it, of course, all the way out to the 4 meter. And each one, you're going to see how much time it takes to get there. Okay, now, next I'll show you an example of how to do that. So now I've got my airplane, got the stopwatch set up, and it's as simple as this. I'm only going to throw it 1 meter. And if you listen carefully, you might be able to hear it hit. Okay, so here we go. And that took only 0.77 seconds. Going back to your lab, you would put that in the first trial right in there. Okay? Yeah, right there. Of course, you'd have to do it 3 more times. You're going to add them up, divide by 3 to get their average times. And then below, here is where you will calculate their average speeds. My suggestion for you on making this lab is to put it into Notability. But that's just my suggestion. Anyways, so you get your average speeds, and then you'll need to graph it. Now, I've got some example graphs down here. It says, remove these examples and insert your own, because this is not real data. I just made this up. Like, I just drew a graph for you and I threw a line on there. I just wanted you to see how the graph should be set up. You'll have your average speed on the y-axis in meters per second and the distance thrown. Maybe you want to go out to 5. I don't know. Maybe you want to go out to 10, but distance thrown is on the x-axis. And as you can see, just by looking at this data that I made up, this is not the answers, but so here is my data, and you can see I put a best fit line through the data, and it looks like the further I throw it, the higher the average speed. That would be just a quick look. If you want to use a different graphing method, this is from the quick graph. You can use that as well. Notice that, again, I put average speed on the y-axis, and I put in meters/seconds, and distance thrown on the x-axis, which makes a nice little title there. All right, so that pretty much is the entire airplane lab. You're going to throw it 1, 2, 3, and 4 meters, time it, figure out their average speed, take some data. I do want you to explain yourself at the end, and then hopefully you'll have time to do something fun, like just make a bunch of paper airplanes, throw them around, see what happens when you change the wings. Maybe you can cut little flaps in them. Add weight to it. I don't know. Have fun with it. Hope you enjoy this lab. Talk to you later.